Hi, dear students. How are you all? Hope you all are passing safe and sound life in this very uh, unusual situation. We have to continue our life. That's why we are arranging this online class to support you from long distance, as we are unable to hold the classes directly. Alternatively, we are holding this class. So try to be attentive and be self-motivated to continue your studies, because now you are staying alone and no teachers are there to remind you or encourage you always regularly to concentrate in your studies and to improve your studies. Now many things you have to uh, manage by yourself. So again I request you all to be self organized, self disciplined, so that you can continue your study life as the time is going on. In our last video we started the topic current, electricity and DC circuits from the beginning, and there I gave you very basic idea of the topic, that is related to current. What is current? What is EMF? What is potential difference? A link between EMF and potential difference, and many more things related to EMF and potential difference. Now we are going to discuss the next content, that is related to very fundamental law of electricity, that is Ohm's law. George Simon Ohm is a very famous scientist who contributed in electricity a lot, and according to his name there is one unit named as ohm. You know resistance, and its unit is ohm, and it is the unit named after the name of the scientist George Simon Ohm. So his law is, he made one experiment to make this law, and we will also discuss that experiment little bit. We are going to discuss that one. Before that, what is his law? Let's try to understand that one. The law is voltage is directly proportional to current. if the temperature remains constant. That means if we applied voltage in a component, for example one resistor, then the current through it will be directly proportional to the voltage applied. Directly proportional means if we increase voltage, then current will also increase. If we decrease the voltage, then current also will decrease. So if it is directly proportional, then according to mathematical rules, there must be one constant, and we are going to show that one now. Look, the first line here I am showing you here, Ohm's law. V is directly proportional to I. V is here voltage and I is current. V is here voltage and I is current. And just below the law I gave in bracket the condition for this law, that is if temperature is constant. That means this law will work only if the temperature is constant. Temperature of the conductor, temperature of the surrounding area should be constant, then this law works. And the next line, you see I wrote V equals IR. That one I just told now, that according to mathematical rule, if there are two variables like V and I are directly proportional, there must be another quantity over there. We just gave here as R. V equals IR, and R is here proportionality constant. R is here proportionality constant. Look, I wrote here proportionality constant, and this proportionality constant is known as resistance of the conductor. You know, here if you don't use any resistor here, then it will show the resistance of the wire. We can also add resistor to understand the law. And the quantity resistance, from the name you understand that it's resisting something. That means it's resists the flow of electrons. That's why the name came resistance. It resists the flow of electrons in a conductor. That's why this quantity is known as resistance. And SI unit of resistance is ohm. That one you see in bracket, in short, the Greek letter omega. You can write this way, or you can write as OHM, ohm. Now you understand about Ohm's law. So this law is temperature dependent. That means if the temperature is not constant, this law will not work. This one is very important thing we have to remember. And I told you that we will discuss one experiment to understand Ohm's law. In your book, if you go through page number 286, Uh, there also this law uh, is discussed, and there is also the experiment mentioned over there to verify the law. Now I am also showing you, trying to explain how this experiment is working to verify this law. We need one power supply over there to supply the to get the voltage, and besides we need one ammeter to measure the current, which will be connected in the circuit in series, and we need also one voltmeter to get the voltage or to measure the voltage. We need one fixed resistor. Fixed resistor means the resistance of the resistor is constant, and finally we need one variable resistor to vary the voltage or vary the potential difference. So how this one is working, let's understand from the diagram. Here is the circuit diagram of this experiment. You see there is power supply, there is one switch, there is ammeter A, the voltmeter is connected across the fixed resistor, and there is one variable resistor. We are getting the current for the entire circuit. That means the circuit is series circuit, so the current is shown for the entire circuit. For each of the resistors, everywhere the current is same, because current is not divided anywhere, there is no branches, current is going through a single path. And the voltmeter is connected across the fixed resistor, so that we are getting the voltage across this resistor. We can measure the voltage across the fixed resistor, and we can understand the law from the readings. If we close the switch, then the circuit is on, and we can measure the readings. I prepared one table over here. Look, I gave here 3 rows. In the first column I gave voltage, which is measured in volt, then current I measured in ampere, then by the formula, already you got the formula, V equals IR. Then if you rearrange the formula, V by I, that is R, resistance, we can calculate in the third row. So I gave here some readings. For example, when the voltage is given 2 volt, that means across the resistor the voltage is 2 volt. If we vary the resistance of the variable resistor, then according to the potential divider rule, the voltage varies, and as the total resistance of the circuit varies, that's why the current also varies. For total resistance or combined resistance for resistors connected in series, we will know in the next video, and also we will know what is called potential divider and how potential divider works in our next in the last video, fourth video, we will get that one. Now look, here we got for 2 volt the current is 1 ampere. For 4 volt voltage is 4 volt, then the current is 2 amperes. Then this way it increases. For 6 volt it is 3 amperes, for 8 volt it is 4 amperes, then for 10 volt it is 5 amperes. And if we calculate using the formula V by I equals R, then always we are getting 2. Again we are also verifying this formula by using the graph here. We can we can plot a graph here. This graph, in the y-axis we plotted V voltage, and x-axis we are giving current. Then if we put the values we got in the table in the graph, we are getting one straight line. This straight line is showing us that voltage and current are directly proportional to each other. If we get the gradient, if we calculate the gradient, then we are getting voltage by current, and that is you see I took here 2 points, the first point and the last point, and I made a triangle, and for this triangle the voltage part we are getting 10 minus 2 8 volt, and for current part we are getting 5 minus 1, that is 4 ampere. You know how to calculate the gradient. You know y2 minus y1 divided by x2 minus x1. I just made it shorter and showed the calculation over here. 8 volt by 4 ampere, so the gradient also comes 2 ohms. So from this experiment also we understood that voltage is directly proportional to the current, and this graph is showing us that voltage and current, if they are directly proportional, then we can get the gradient everywhere. As it is straight line, if you calculate anywhere of the graph, if you can take the gradient anywhere of the graph, then you will get the same value of the gradient, that is 2 ohms. So the law is verified here by this experiment. Now in this law we already said that this law only works if the temperature is constant. Now we will bring one example that how it is temperature dependent, to understand it more deeply. Like think of the filament lamp. It's easier for us to understand. In filament lamp we get the light due to the heat of the filament. If the filament is more heated, then the light glows more. So if the filament is heated more, that means the temperature of the filament is more. So in this higher temperature we observed that if we increase the voltage, the current does not increase directly proportional. That means the current is not increase so much, current increases less. from the graph we can understand it more easier, like this one. You see, in this graph, when for the time being or for a while it goes with directly proportional, but if the voltage we increase more and more, then the current is more. That means the filament is heated, and that time the temperature is more, and it's no more straight line over here. It's no more straight line over here. Here we see we are increasing the voltage, but the current is not increasing that much the way it was increasing before. So if we get the gradient over here, what happens? If we take V by I, that means we are getting the resistance. Look, I am writing here. If we get the V by I here, that is R, it is the gradient. So this gradient, as V is here at the top and I is down, so that is V is here numerator and I is the denominator. So if you take the ratio, R will increase. So we can decide that with temperature increase, the resistance of the conductor increases, and the graph you see where it is a straight line, that part is following Ohm's law, but the other part, which one is curved, that part is not following the Ohm's law, that is not directly proportional. So the conductor or the device which does not follow the Ohm's law, that is called non-ohmic conductor. So filament lamp does not follow the Ohm's law completely, that's why it is called a non-ohmic conductor. So from today's class we understood Ohm's law, and we also brought the idea or the experiment to verify the law. Finally, we understood that the conductors, when its temperature increases, then its resistance also increases. That means we don't get that much current that time with the increase of voltage. So thank you so much for listening, and hope you understood what I discussed. Even after that, if you have any queries, please ask your questions. Please you write your queries in the comment link in the Google Classroom. I will answer your all questions. Stay safe and stay healthy. God bless you. See you again in the next video. Our next video will let you know the resistors, if they are connected in series, then how can we calculate the resistance? If they are connected in parallel, how we will calculate them? We will also discuss another quantity, that is resistivity, resistivity of an element of a conductor, and finally we will discuss light dependent resistor. till then you study and continue with this video, try to understand this. See you again, best of luck.